are going to use our transformation formed here. This is how the cubic function looks like originally, something like this here, like that's the 1 1 and that's negative 1 and 1, something like that here. So this is how the cubic function looks like. So that's where the saddle point is, like that's where the point of inflection, we call that as a saddle point, and this is the saddle point right over there. Looks like this point here is just moved it up over there. So like we've moved 5 units up and then we moved to the right by 3 units, so we know the direction over there. So that means that's why for this function here, using the transformation is gonna be the easier. So transformation looks something like this here: y equals to a brackets k brackets x minus the d to the whole power, because the cubic function here, that means that for the cubic function the degree is gonna be 3, so the exponent on that here is gonna be 3, then plus the c here. So this is how the cubic polynomial function looks like in the transformation formed. Now there is a and the k here. Now for one of these values, a or k, you can take that as a 1, and it's always easier to take the k as equals to 1. So we're going to say let k will be equals to positive 1, then k is 1 here, so it's gonna be y equals to a, k here is 1 brackets x minus d to the power of 3 here plus c. Everything is same, just we replace the k with the 1, and you see 1 times x, that will be just the x, 1 times negative d, that's gonna be negative d. So we have y equals to a, 1 times x will be just the x here, then 1 times negative d will be just the negative d, then to the power of 3 plus c. Now, finding the D and the C. What is gonna be the D and the C values here? Now, D means shifting the graph right or left. Now, if we're going to shift the graph to the right, it's gonna be the positive number. But if we shift the graph to the left, it's a negative number. Now, notice one thing here. This point right over there is like we shifted up by 5 unit, then moving to the right by 3. That's what the d is. We are moving right here, so that's d. How many units we are moving? We are moving to the right by 1, 2 and then 3 units here. So that means the d here is gonna be 3, because there is actually a horizontal translation. We are shifting the graph to the right by 3 units, so d here is gonna be the positive 3. Next up, the C here. C here means the vertical translation. Maybe we're shifting the graph up or down here. That's what the vertical translation is. That's what the C is. If the C is positive, we're going to shift it up. If it's negative, we're going to shift it down. So here we were shifting the point 5 units up here. So that will be positive 5, because we are moving it up. So we know the D and the C, we know the translations here. So we're going to substitute right into the equation here. So A we don't know yet. Then the x minus D, we just know the D value. The D here is 3 here, to the power of 3 plus the C. C is positive 5. Now we have, remember, if you're finding the equation, so this is the format here, we let the k equals to 1, no need to write that. Now whenever your equation looks something like this, it's important to find out the a value, the d value and the c values here. And out of the a, d, c, we already have the d and the c, needs to find out the a now. So how we can find out the a value here? So on the graph, just pick any point on the graph here. The graph that we have here, pick any point, doesn't matter. Don't estimate any point here, like this point right over there, you don't need to estimate. I can either use the A point, B point or C here, go for any. I'm gonna just use this here. A is 3, the X is 3 here and the Y is 5. So we're gonna replace the Y here, 5. A we don't know yet. X here is 3 minus, there is already 3 in the equation, to the power of 3 plus 5. And now we just need to simplify the right side here. So leave the 5 as it is. Then we have this a here. Then 3 minus 3, that's a 0 here, to the power of 3. We were, yep. Then plus the 5 here. Now notice one thing here. If I'm going to, okay, why, what's happened here? So when we replace the 3 here for the x and the replace the y with the 5 here, it's giving me 0. What's wrong with that here? Because 0 times a will be 0. There will be no a anymore here. Let me tell you, because remember that we already used this point 3 and the 5 here, because the 3 was the d value here and the 5 was the c value. So because we were shifting, because the saddle point was here, we were shifting up by 5 units and moving to the right by 3 units here. That's why we already used this point here, so we cannot use the same point one more time in the equation. So use the different point. I can either use the a point here or I can either use the c point. Go for any, doesn't matter, but don't use the point that we already used it in the equation. Okay, that's why it's giving us the crazy 0 0 over there, which is we don't want it. So let's go back. Let's replace the x and the y with something else. Let's use the a point here. In the a point, the x is 2, y is 7. So y will be 7, x will be 2. Let's see, 7 stays the same, simplifying the right side. So there is a here. 2 minus 3, that's negative 1 to the power of 3, then plus 5. Now remember, we are simplifying the right side, so 7 stays the same for now. Then there is a here. Negative 1 to the power of 3 means negative 1 times negative 1 times negative 1. That will be negative 1, then plus 5. Now remember, a times negative 1, that's just gonna be negative 1a. Then there is plus 5. So we can solve for the a here. 5 is adding. If I move that 5 to the other side, it's gonna be negative. So 7 minus 5. Here we have negative 1a. 7 minus 5 is negative 2. Over there is a negative 1a. Okay, any doubt, any question here for the, oh, 7 minus 5 is actually positive 2 here, right? Not negative 2. Do you understand so far? Great. Alright, so negative 1 is multiplying with the a. So if I move it to the other side, it's gonna divide. So 2 will divide by negative 1. Here we have the a. 2 divided by negative 1 is negative 2. There we have the a value, and that's what we all want. We just need to want, in this equation, we just need to find out the a value. And the a is negative 2. So we're gonna have y equals to, just replace the a, which is negative 2. Then we're gonna have x minus the d is 3 here to the power of 3 plus the 5 here. Now that is what the equation is gonna look here. This is the answer. Now when you are going to check it on the Desmos, you're gonna find out the graph will look exactly the same as this one.